Hello folks. Okay, this time we want to get into a slightly meatier example of bash scripting. So it's not at all unusual for our programs to need to go through a directory and everything in its subdirectories and everything in their subdirectories and everything in their subdirectories, etc., etc., etc. So this idea of carrying out some sort of exploration or traversal of everything in a directory is pretty common. And what we'll look at today is a recursive structure to carry that out. So the actual program that we're going to write, or the function that we're going to write, is going to try and search a directory and all of its subdirectories looking for a Git repository. So the way that we'll do that is we're going to base it on the idea that a Git repository in its root has a subdirectory named .git. So what our program will do, what our function will do, is say, okay, well, I'm going to look in the top directory and see if it contains a .git. If it doesn't, then I've got to dig deeper. So I'm going to look in each of the subdirectories and see if any of those contain .gits, and so on down the line. And if I explore everywhere and don't find one, well, that's just the way it is. But if I find one, I can stop. Found one. So in this case, I think we're actually going to see if we can identify all of the Git repositories that we find. So we'll do a little bit of basic error checking first. So the first thing our function is going to expect the name of the directory to search, the top level directory. So the first thing we'll do is make sure that we actually got past a parameter and make sure that it actually represents a directory name and that that directory is readable and is executable so that we can actually get into it and see what's in it and explore it. If we get past that, then we'll check to make sure, or to see whether or not it is the root of a Git repository. So if that top level is a Git repository, if it contains a .git subdirectory, then you can't have repositories inside repositories. So we'll just assume, okay, that's our Git repo. We'll say, yep, found one, print it out, and return. If it doesn't contain a .git subdirectory, so it isn't the root of a Git repository, then we'll go through and call the function recursively on each subdirectory. So this is the basic structure that we want to go with. So the code doesn't actually wind up being too terribly bad. We'll take a look at the first part of it. So I'm just going to call this function search. We'll do the error checking first. So again, the idea was we want to make sure that they gave us a parameter. So if they didn't give us a parameter, if the number of parameters is not equal to 1, I think there should be spaces around those square brackets inside, then we'll return 0, right? Just bail out. If we get past that, then they did pass us a parameter, so we'll check and see if it represents a directory name. So we'll grab that name, whatever that parameter is, store it in a variable. I'm just going to call it dir. Make sure that it's not an empty string. And then we'll go through and say, okay, what have we got going on? If it is a directory, then we'll go, I didn't actually check to see if it's executable and readable in here. I should actually throw in checks here for -r and -x to make sure that we can get into it. Yeah, that would be a good plan. So we could have a couple of elifs here. If it's not executable, bail out. If it's not readable, bail out. Otherwise, if it is a directory, then it's something we can process. So the first thing we'll do, having decided that yes, it is a directory, it is readable, it is executable, we'll check and see if it contains a subdirectory named .git. So the way I'm going to do it here, just to keep things a little bit cleaner, is to put the name that the subdirectory would have into a local variable. So it would be the name of the current directory followed by the .git, right, the /.git. So we'll then check and see if that directory exists. If it does, then we've found our repository. So if there is a directory with that name, then hey, we found it, and we're done. If there isn't a subdirectory with that name, then we have to go and do our recursive search. So what I'm going to do is use my for in to check everything that's in that directory. So I'm going to say for file in, and here we're using our globbing to go through and capture the names of everything that's in that directory, all of the files and all of the subdirectories. So for everything that starts with that directory name, followed by the slash, right, and then the asterisk to capture everything that's in there. So for everything that's in there, if it is a directory, then we'll call recursively on that. Right? So we can go through and process everything in the subdirectory. And again, since this is recursive, when search goes through to work on the current, on the whatever subdirectory you've passed to it, it will go through and see if, you know, that one is a directory, if it's readable and executable, and then see if it's got a .git in it, and if not, it will call itself recursively on all of the subdirectories of that subdirectory. And so you can work out this idea of a recursive traversal. And again, the structure of it is not that complicated. Right? The syntax is something you have to be a little careful with, right? You have to remember that when we're talking about the .git subdirectory, you have to make sure that you remember that it does need to be a subdirectory of the current one. And when we're doing the recursive explorations, right, we want to make sure we go through and say, okay, well, I want to search all of the files that are in the current directory that we're exploring right now. But beyond that, it should work relatively well. Now, this is the kind of thing that you're going to be doing as part of Lab 2, I believe. So one of the components of Lab 2, essentially the Bash scripting lab, is going to be arranging something that does a recursive traversal like this. All right, we will leave it there and come back with more exploration next time.